Determine the implied domains and ranges for each of the following relations. So for A, we have y equals 1 divided by x plus 2. So this is a hyperbola graph, and its graph below. So the first thing we want to do is look at the domain. So the domain of this graph is going to be x is an element of, because the domain is the set of all the first elements in an ordered pair. And we need to look for all of the x values that do have meaning for this rule. And if you have a look at the graph, every x value except x equals -2 fits into this rule. And that's because when x is -2, we have 1 divided by 0, which is not possible. So we can say x is an element of -infinity not included to -2 not included, union with -2 to infinity. A more concise way of writing that might be x is an element of the real numbers excluding -2. Next, we want to look at the range. So the range of this same rule. So all y values come out of this rule excluding y equals 0. So we can write this as y is an element of -infinity to 0 not included, union with 0 to infinity. A more concise way of writing this might be y is an element of the real number system excluding the set of 0. Next, we want to look at example B, which is y equals 1 divided by x minus 1 all squared plus 2, and you should be able to recognize that as a truncus graph. So the first thing we want to do is look at the domain, and the domain is all the x values that have meaning, and for this, all x values excluding 1 have meaning, and that's because if we sub x equals 1 in there, we have 1 divided by 0, and that's not possible. So for this, we can say x is an element of -infinity to 1 not included, union with 1 to infinity. A more concise way of writing that might be x is an element of the real number system excluding the set of 1. Next, we want to look at the range of this relation. So this is y is an element of, it's all of the y values that are generated by the rule. And from this, you can see that the y values start at y equals 2 not included. So it goes from 2 not included all the way up to infinity. Finally, we have a look at example C, and this is a square root graph. So its graph below, and we can see the domain and range easily from the graph. So the domain, which is all the x values that have meaning, are going to be x is an element of, and the smallest possible x value is -2.25, and that is included, so we use a square bracket, so it's -2.25, and all other x values up to infinity are possible, and we use a rounded bracket when we specify infinity using interval notation. Finally, the range of this square root relation is going to be y is an element of, and the smallest possible y value is -infinity, and again we use a rounded bracket for the infinities. And the largest y value is this 0 here, and again that's included, so we have 0 with a square bracket. So that is the range of this square root graph.